Okay, let's go learn nutrients. But first, what term nutrients means in dictionary? Nutrient, substance that an organism, like plant too, must obtain from its surrounds for growth and the sustenance of life. Sustenance means such as food that keeps someone or something alive. Something that gives support, help, or strength. Okay, substrates that used as a food by organism or plant. So-called non-essential nutrients are those that can be synthesized by the cell if they are absent from the food. Essential nutrients cannot be synthesized within the cell and must be present in the food. In some animals, microorganisms living in the gut may synthesize essential nutrients, which are then released into the bloodstream. In most living organisms, nutrients provide not only the energy necessary for certain vital processes, but also the various materials from which all structural and functional components can be assembled. See also metabolism, nutrition, and nutrition human. Make pause and I found article. Firstly, we read about chemical reactions and equations. I want to know how read chemical reactions. Let's try to understand. Learning objectives. Interpret chemical equation. A chemical equation like that. I interpret a chemical equation to identify the reactants, products, and their relative quantities. Balance of chemical equation to reflect the conversation of atoms during a chemical reaction. Sorry. Chemical reactions are at the heart of chemistry. They drive everything from the discovery of new medicines to the development of cleaner fuels and advanced materials. In a chemical reaction, atoms are rearranged to form new substances with new properties. Chemists use chemical equations to represent these changes in a clear symbolic way. A chemical equation shows what substances react, called reactants, reactant 1, reactant 2, and what substances are produced. CH for atoms, hydrogen and carbon atom, plus 2 oxygen. These rearranged. These two atoms put it into carbon connected. See this? And these hydrogen atoms are connected to these. And we get two water atoms, H2 oxygen. And what substances are produced? Called products. The formulas of the substances appear on either side of a reaction row. And coefficients. Two atoms 1, 2, 2 molecules. This call it molecule because this combine it with atom. 1, 2, 3. 2 molecules produced. This coefficient say 2 molecules. 1, 2. But you can confused. What this means too? This means 2 atoms hydrogen. 2 atoms hydrogen. Hydrogen 2. 1 oxygen. 2 hydrogen. 1 molecule. But coefficients say we get 2 molecules. 1 molecule, second molecule. And coefficients in front of each formula tell us how many particles or moles are involved. Moles, or how many molecules we have. A unit to measure molecules, I think, can be not true. For example, the combustion of methane is shown in figure 1. One methane molecule reacts with 2 oxygen molecules to form 1 carbon dioxide molecule and 2 water molecules. Reactant side, product side, reactant 1, 2, 2 molecules of oxygen. This oxygen, 1 oxygen, 1 atom, second atom, or just molecule, 2 molecules. We're reading, for example, yes, 1 methane molecule reacts with 2 oxygen molecules to form 1 carbon dioxide. D means 2. Oxide means oxygen atom. Oxygen. If we get 1 oxygen atom without this atom, we say carbon oxide. But we have 2 oxygen atoms connected to carbon atom, and we say carbon dioxide. 2 carbon plus 2 oxygen atoms, in other words. Okay, 1 methane molecule reacts with 2 oxygen molecules to form 1 carbon dioxide molecule and 2 water molecules. The reaction between methane and oxygen to produce carbon dioxide and water. The top shows a balanced chemical equation using formulas. The chemical equations or formulas represent boroatom models, or just atoms, molecules, and how they react. This example shows the key parts of any chemical equations. First, reactants are listed on the left side of the arrow. Reactants, left side. Products side are listed on the right side of the arrow. Okay. One component mixed with secondary component, and we get combination, and the result can be differently. We get product, in the term 3. The plus signs plus separate different substances. Substance 1, substance 2, or component 1, component 2, or molecule 1, molecule 2, plus summaries, and we get rearrange. Rearrange means the atoms disconnects and connects to other atoms, like that. Every atom of hydrogen connects to the oxygen by 2, maximum 4. An arrow separates the reactant and product left and right sides of the equation. This equation means left side, right side, reactants, products. When descended, coefficients in front of formulas show how many units, how many atoms, molecules or moles are involved. Alright. The chemical equation represents how many of each type of particle is involved, not just what changes. A balanced chemical equation also reflects the level of conservation of mass. Atoms are neither created nor destroyed in a chemical reaction, rather rearranged. Interesting. In a balanced chemical equation, the coefficients tell us the relative number of particles, how much atoms or molecules that react and form products. These numbers can also be used as ratios, and the ratio stays the same. Ratio means this. If you don't know, we can watch video on YouTube and find what is ratio in mass means. But this is just 1 part of water, 2 parts of oil, 1 part of the sand, 2 parts of the apple juice, combine it. We can translate this 1 liter of benzo, 2 liters of water, and this plus in just cap. Okay, these numbers, coefficients, can be also used as ratios, as the ratio stays the same no matter how much actual particles are present. For example, wait a minute, I enable JavaScript to this interpreted as formulas. Okay, for example, in the methane, for example, in one methane combustion reaction, CH4 plus 2 oxygen produced, I can say this, produce CO2 plus CO2 atom and water, 2 atom atoms. On the ratio is 1 atom of methane plus 2 oxygen atoms. Damn it. Molecules. Let's say molecules, not atom. 1 molecule of methane plus 2 molecules of oxygen produced 1 molecule of CO2 and two molecules of water, H2O. The ratio is 1 methane by 2 molecules of oxygen produced 1 molecule of product CO2 and 2 molecules of water. This means 1 molecule of methane reacts with 2 molecules of oxygen to form 1 molecule of carbon dioxide and 2 molecules of water, carbon dioxide, CO2. But this ratio also applies to larger quantities. Mixture before reaction, mixture after reaction. 1 dozen carbon, how this means, methane. 1 dozen methane molecules reacts with 2 dozen oxygen molecules. Other words, we take 1 liter of methane, 2 liters of oxygen, for example. But this measure in moles, or how many molecules. 1 mole of methane reacts with 2 moles of oxygen. We can take 2 cups, dry water in cup, and to measure how much molecules of water we have, we can use unit called as mole. If we imagine this cup with water, we can find molecules, and this can be modeled and represented as this image. Okay, let's continue. 1 mole of methane reacts to moles of oxygen. We take cup, we take methane 1 liter and put into cup. We take oxygen 2 liters, put this into, and we mix this and get mixture of carbon dioxide 1 mole or 1 dozen, and we get 2 dozen of water or 2 moles. Other words, if we take methane and oxygen, we get carbon dioxide in water. I think this can be like water with dark color, or not dark, I don't know, maybe clear. Whether we are looking at individual molecules or many molecules, the ratios between reactants and products stay the same. This is the basis of the stoichiometric calculations. Okay, balancing equations. A balanced chemical equation shows equal numbers of each type of atom. A balanced chemical equation. This equation too, like mathematical operation plus and equal to this. A balanced chemical equation show equal numbers of each type 1, type 2, each type of atom, each type of molecule in this example. These molecules, because molecule combined with atoms, I think. A balanced chemical equation shows equal numbers of each type of molecule on both sides of the row of each type of atom on both sides of the row. This is required by the law of conservation of mass. I don't know what it means. Atoms are not created or destroyed in chemical reactions, just rearranged. Just atoms disconnect to connect other atoms. The chemical equations described above figure 1 for 1 is balanced. Whether we are looking at individual molecules or many molecules, the molecules, the radius between reactants and products stays the same. This is the basis of stoichiometric calculations. Okay, to balance an equation, you can change the coefficients, the numbers in front of chemical formulas, the numbers of molecules. Two molecules, one carbon dioxide. Subscripts inside formulas cannot be changed. Subscripts means this subscript, the two atom of hydrogen. He say cannot be changed. At this void change the identifier of the substrate. Subscript inside formulas cannot be changed, as this void change the identity of the substrate of molecule. If we change this change our molecule. And consider the following example. I don't know how this were true, but okay. Consider the following example. Unbalanced. Water divided in hydrogen and oxygen. How this can be made? I know if we put two copper wires into water, imagine we have a tank and we put water and two copper wires. We put electricity and water make bubbles. Oxygen or water divide into hydrogen and oxygen. Take a minute. Hydrolysis process. I make pause. Okay, I found. Check this. This is water molecule. H2O, 2 hydrogen and 1 oxygen molecules. When we put electricity via copper wires, the water divides to hydrogen and oxygen. You see bubbles. I think this is oxygen molecule or atom, and oxygen means air, and his uptake electricity makes potentials, and ions or electrons moves to minus to plus in divide or molecule of water, and this oxygen disconnect in path to up. I don't know truly I or not. You can read about process pyrolysis reaction. Okay. About chemistry, you can use Khan Academy section chemistry high school, but it's very easy to understand if can you can try to understand basis of Boron theory of item, but this has wave theory of item, different theories, but this theory Boron works, and we learn for hydroponics this. In Orgos, this I think can be. Okay, continue. Consider the following example and balance it. In this form, there are two hydrogen atoms on both sides, one oxygen atom on the left and two of the right, not balanced. What? What's from oxygen atom? To fix this we can. This is incorrect equation. Okay. To fix this we can put it to in front of oxygen. Oh, sorry. To fix this we can put to in front of H2O like that. We add a number 2 that represent how much molecules we have. 2 molecules of water in hydrolysis produce 2 hydrogen atoms and 2 oxygen atoms. Okay. I think that is not correct. We has 2 atoms of water. This means we has hydrogen 1, 2, 3, 4, because 2 atoms. Let's see. We has 2 molecules. How much hydrogen we has in 2 molecules? In 1 molecule we has 1 hydrogen, secondary hydrogen. We say we has 2 molecules. Hydrogen in 1 molecule, 2. In second molecules, hydrogen 1, 2, 3, 4. We has 4. We need multiply this number to find how much hydrogen atoms we has. These equations can be made by ChatGPT to avoid errors and mistakes and hard equations like calculator. I think calculators can be found. We need to understand the principles. to understand how read these equations when read the books. This help is in next chapter 5. You can see carbon dioxide, 6 molecules of carbon dioxide plus light, water, sugar. Oh, this reactants product. Carbon dioxide plus water gives sugar and oxygen. Light produce this reaction. Okay, I understand. Okay, put the 2 in front of water molecule. 2 water molecules produce hydrogen 2, hydrogen 4, oxygen 2 to give 2 oxygen atoms of each side. That gives us 4 hydrogen atoms on the left and only 2 on the right. But add 2 in the front of hydrogen 2. Like that. See, you see this? 2 molecules of water produces, and by operation like hydrolysis, oxygen atom that connects to hydrogen, but 2 hydrogen. I don't understand. Let's try to understand. Represent in imagine, visualize 2 hydrogen. Let's try 2 hydrogen molecules, items divides to oxygen. Um, 2 hydrogen molecules, H represent this white, and oxygen represents red circle. We say we get 2 hydrogen plus 2 oxygen. We put coefficient. This means we need multiply 2 by 2 equal 4 hydrogens. If we multiply 2 by 2, we get 4 hydrogens. In this formulation, we put coefficient into here. We divide this part and this. But what from to in here? But in front to here. Strange equation. I need to understand what from oxygen to hydrogen into oxygen. But in this equation, we have 2 hydrogen and 1 oxygen. He say unbalanced. He say we try balance this equation. We put 2 and this make balance because 2 oxygens in here. 2 oxygens. We have 2 molecules. This means we have 4 hydrogen and 2 oxygens. The real formulations means 4 hydrogen and 2 oxygen. But this formulation write it in the other side. Put 2 in the front 2 molecules of water produces 4 hydrogen and 2 oxygen. Now the equation is balanced. 4 hydrogen atoms on both sides. 2 oxygen atoms on both sides. One side, two sides. In here, 4 hydrogens. In here, 4 hydrogens. In here, oxygen multiplied 2 equals 2. We get, in this side, 2 oxygens. This carries the balanced equations. Balanced chemical equations often take a bit of trial and error. Start with the most complex formula and balance one element at a time. Example 1 for 1 balanced chemical equations. Write a balanced equation for the reaction of molecular nitrogen and oxygen to form the nitrogen pentoxides. Pent means 5 oxide, 5 oxide. Dinitrogen, D means 2 nitrogen oxide or dinitrogen pentoxide. Solution. Start with the unbalanced equation. Nitrogen 2 plus oxygen 2 produces D nitrogen pent oxygen pentooxide. Dinitrogen pentooxide. Strange name. Nitrogen is already balanced. What from 5? We has only 2. I think we need add a number, but where? 2 by 2, 4. 3 by 2, 6. How to balance this? Strange. Nitrogen is already balanced to atoms of each side. Yes, 2 atoms nitrogen in left and right side is balanced, but oxygen unbalanced. It is not correctly formulation. Nitrogen is already balanced, 2 atoms on each side, but the oxygen atoms are not. There are 2 oxygen atoms on the left side and 5 on the right side. To get the same number of oxygen atoms on both sides, multiply oxygen 2 by 5 and nitrogen oxygen 5 by 2. That gives us 10 oxygen atoms on each side. What? 5 by 5 multiply 2 gives 10 oxygens. Nitrogen. What? To get the same number means balanced equation. To get the same number of oxygen atoms on both sides, multiply oxygen by 5 and nitrogen 2 oxygen 5 by 2. The left side and the right side change it to balance of oxygen. 2 nitrogens 5 10 oxygens 5 multiply 10 2 give 10. produces there is a mix to compound substrates. Nitrogen we get nitrogen gap and second gap with oxygen and nitrogen. We mix this and we get two. We say we have two molecules of nitrogen. 2 by 2, 4 nitrogen. 1 4. And 2 by 5 is a 10. It's a 10. 10 oxygens. 4 nitrogen and 10 oxygen. Alright. Now we have 4 nitrogen atoms on each side, 10 oxygen atoms of each side balanced in here. 2 nitrogen and 5 oxygen. No. I skipped this section. Now nitrogen is unbalanced. There are 2 nitrogen atoms. Yes. There are 2 nitrogen atoms on the left. And 4 on the right. Yes. To fix this, place a 2 in the front of nitrogen 2. And the left side, in here we add 2 by 2, 4. And in the left side we have 4 nitrogens. And the right side we have 2 nitrogens. On the left side we have 10 oxygens. And the right side we have 2 by 5, 10 oxygens. 5 multiplied 5 by 2 equal 10. 2 by 5 equal 10 oxygens. Now we have 4 nitrogen atoms on each side and 10 oxygen atoms on each side. The equation is balanced. Okay, very hard to understand because this needs to imagine or mathematical operations. We can just use ChatGPT for this. We live in the technological time and not needs hard works. Hard equations, I mean. Exercise. Write the balanced equations for the reaction of aluminium metal with a chlorine gas to form aluminium chloride. Aluminium plus chloro2. I cannot write subscript. I can write underscore to say this little. Okay, these produce 1 atom of aluminium. No. How does it balance it? How this started? I start with this and aluminium chlor. I not understand how to balance. Start with unbalanced equation. Aluminium plus chlor. 1 atom metal, aluminium metal plus 2 chlorine gas atoms. Aluminium chloride. 3 the future, if you want to write reactions, if you want to know what from free, how I know in boron theory, we has property of each atom as how much electrons and protons atom has. If electrons is so much, the number you can see this index with +2 or -2. This means how much electrons lost of gives or protons lost of gives. And this skeleton ions, how I know, and this can affects to this number, because ions can electrons of each atom can flow it to another and makes additional atom. Okay, we start with balancing the equation, and we need add the new atom. If I add this, what this means? 2 by 2 equal form. What if I do the 3, the 6? What if 6? 6 to 6 to 6 by 2, that is 20. 1 aluminium and 20. Okay, answer. What? We're right. Stop. 1 aluminium atom, 6 chlor atoms, molecules. Nitrogen is already balanced, but oxygen atoms are not. If we add this, why to add it in here? Because this number affects nitrogen and oxygen. But not understand. If I add in here too, no. This free will not change subscripts. I forgot about it. Subscripts in subformats cannot be changed. Okay, I not change fucking subscript. Let's again. Okay, let's write two in here. Let's in here two aluminiums. In here I see unbalanced. Let's 2 by 3 the 6. If I add 6 in here, how this affects 2 aluminium, 6 by 2 is 20, 2 by 3 is a 9, 4 by the 20, 4 aluminium, 4 by 3, 20 chlors, for aluminiums. I just change this form and see answer. 2 aluminiums by 3 floors. Okay. Change aluminium and see how this affects. This I clear and not check. 2 by 3 equals 6 atoms of chlor. In here I need to add number that makes 6. 2 by 3 equal 6. And check answer of 2 aluminiums, 3 chlors, 3 by 2 is 6 chlors. 6 items, and here 2 by 3 that is 6. Yes, this is correct equation, but I make mistake in subscripts. Inside formulas not changed. Additional information in chemical equations. Chemical equations often include physical states of the substances involved. They are shown in parentheses of each formula. Solid S, liquid L, G, gas, aqueous, aqueous, dissolved in water. For example, 2 natria solid to natria like powder, plus water produced 2 natria wash, and powder or solid natrium in the water plus gas. Oh, this is useful. This is really useful. Stays really useful. This equation shows that solid sodium reacts with liquid water to form aqueous sodium hydroxide and hydrogen gas. Summary. Chemical reactions involve the arrangement of atoms to form new substances. Chemical equations use formulas and symbols to represent what happens during a reaction. Reactants appears on the left side of the arrow and products appear on the right. Coefficients show the relative number of particles or moles involved and must be adjusted so that the number of each type of atom is the same on both sides of the equation. This reflects the love of conservation of mass. Understanding how to interpret and balance chemical equations is essential for calculating the amounts of substances involved in a reaction. Okay. Now we can understand the fucking formulas, and these states very useful. I can understand where rocks made it in the powder, added in the liquid, and what this give in a reaction. Alright. Okay, in the part 2 we read about macroelements and microelements. And maybe watch video about atoms in the Khan Academy. Or I just edit in archive.